Here's our solid. Gotten this solid by revolutions. Yeah. Okay. So what we're going to do is first make note of this shape right here, this function. You guys see this function? What is this function? It is the square root of x. Okay, very simple. Okay, this function is square root of x. And then when we rotated this function around the x-axis, this is what we got. We got this shape. What are the cross sections of the shape? They're circles. Or you can call them discs. All right, so this is how we find the volume of this shape. This is a volume of revolution. So here we go. The first thing we're going to need is we're going to need our area function. I'm going to follow the same model as our last section, which is finding area of solids using cross sections. And so the area is the area of the circle, the disc. Okay? What is the area of our disc? Okay, so I'm going to say, what is that? That's it's going to be pi n squared. All right. Well, what is n? N is your radius. N is representative of this. Oh, you can't even see that. What if I draw right here? Yeah, so this right here, this is the n. So if I drew a circle all the way around, your n is the radius. Notice what the n is. And that's our next job. What is our n? What is the function of n? Now I want to write n in terms of x. Why? Because my function is in terms of x and we're rotating around the x-axis. Or you can say that the n is perpendicular to the x-axis, just like our other volumes of using cross sections that we did before. Okay, so what is our n in this case? How do we define the distance from here to here? In this scenario, it is just a function. Now, why is it just a function? How come I don't have to subtract anything for this one? Because the bottom function is the x-axis. Now, you could subtract 0, but, it's kind of redundant. Okay, so you can just go square root of x. If you plug in any x number right here, it'll give you a y number up here, which happens to be the distance of our radius. Is everybody's tracking with me? Okay, all right, so we already did those first two steps so far. Now what we have to do is we have to do an integral. We have to find the area of every single x value and add them together, which is what an integral does. So we're going to plug in the a of x, and this is going to be a dx. This is what we're going to do. So how's that going to look? We got our a, which is pi n squared. But what is our n? It is the square root of x, dx. Now what's our lower and our upper bounds? It's kind of hard to see on this graph right here, but it tells us right here. It says that a is 2 and b is 9. So I just got to go 2 to 9. And then solve. This one's not that bad. We don't need a calculator for this. What is square root of x squared? As x. So we have x. Just chilling there. And you guys see this pi right here? He's known as a scalar. He can be called a scalar right now because he's not going to change anything. So I'm just going to put him out in front. He's going to multiply to whatever we get when we're done. What is the antiderivative of x? What is it? It is x to the second power times 1/2. And then we're going to go 2 to 9. This whole thing is going to be multiplied by pi when I'm finished. So I'm going to go pi times 1/2. And I plug in the 9. I'm going to square that dude. Minus 1/2. And I'm going to plug in the 2 and square that dude. And that should give me my answer. 9 squared is 81. So it's 81 divided by 2. That's 2 squared is 4. So it's 4 divided by 2. So we have pi over 81 divided by 2 minus 2 because 4 divided by 2 is 2. And then I have to do that. Let's see, what is 81 divided by 2? That's going to be 40.5. And I'm going to subtract 2 from that. So we get 38.5 pi. Yeah, I'm going to leave it like that. I mean, like, you can multiply it by pi, but then you get an approximate answer because you're going to have to round. So that's all you have to do. Normally, the problem we just did starts like this. They only give you a function, and they tell you it's revolving around blah, blah, blah. Now here it says y equals 0.011. That's because I couldn't get my volume of revolution exactly on the x-axis, but we're just going to say that this is y equals 0. So that is right here on the x-axis, y equals 0. And so then you're supposed to look at this and go, oh, okay, so if I'm doing a volume of revolution, that means this right here is your radius. Okay, from the x-axis up to the function is your radius. All right, let's try a different one.